Related works. Aiming to optimize the HEVC encoder complexity, several works have been proposed to reduce the test zonal search, TZS, motion estimation algorithm. Some works are interested in hardware solutions, and others are focused on software optimizations. Using sequential and parallel techniques, two hardware diamond architectures for HEVC video coding are proposed. These architectures achieve an encoding in full HD at 30 frames per second using a Vertex 7 field programmable gate array, FPGA, design. Authors have proposed a hardware parallel sum of absolute difference, SAD, design for grayscale images to reduce motion estimation time for block size of 4x4 pixels. A multiplier is exploited for addition as a partial product reduction, PPR. Results obtained on Vertex 2 Xilinx FPGA show that the maximum frequency obtained is 133.2 MHz for 4x4 block size. Naluri et al. Have proposed two other SAD architectures on FPGA Xilinx Vertex without and with parallelism. The proposed parallel architecture has accelerated the SAD calculation by 3.9 times compared to the serial SAD architecture. Authors have proposed two implementations of the SAD and SSD algorithms using NVIDIA GeForce GTX 480 with CUDA language in order to reduce the MI runtime. The proposed architecture saved about 32% of encoding time for Class E video sequences with non-significant degradation in the PSNR and the bitrate. Regarding software solutions, the 8-point square and the 8-point diamond have been replaced by Naluri et al. With a 6-point hexagonal in the TZS-MI algorithm, and 50% in encoding time is saved without degradation in bitrate and PSNR. To replace the TZS algorithm, authors propose small diamond pattern search, SDPS, large diamond pattern search, LDPS, and horizontal diamond search, HDS. Experiments using HM 8.0 showed that these algorithms allow a reduction of 49% of motion estimation calculation time with non-significant increase in bitrate and slight degradation in video quality. Leakin et al. Have proposed a fast mode decision algorithm by skipping some depths. The proposed work allows saving about 21.5% of encoding time with a slight bitrate increase and a negligible efficiency loss coding. The algorithm proposed by Chin uses the ECU algorithm according to an adaptive MSE threshold value. This work ensures time saving without degradation in the quality. Potter has also proposed an interesting software method to reduce the MI time. Based on human visual features, HVF, an efficient decision of the appropriate block partitioning mode has been obtained. This work allows saving 41.44% of the execution time for SCVS video sequences. In the work published in A Fast HEVC based on DS and 3 fast mode decisions, ECU, ESD, and CBF modes, have been presented. Simulation results show a reduction of 56.75% in the complexity of HEVC in terms of execution time, accompanied with slight degradation in video quality and bitrate, when comparing the HM.16.2 executed on an Intel Core TMI7 3770 at 3.4 GHz processor. Authors have tested just one sequence from each class with just two quantification parameters, QPs, QP equals 22 and 37, to evaluate the use of the fast modes. By analyzing all these previous works, we can note that using fast mode decision algorithms represents an interesting technique in order to reduce the HEVC computational complexity.